thanks for the opportunity. Well, I'll briefly present some few results based on this photometric measurements. The main person in this work is Felipe Ferreira. Felipe is a PhD student at Observatório Nacional in Brazil. Okay, so all our photometric information comes from the DAS single level catalogs that comprise observations ranging from 2013 to 2019. Well, as you all know, DAS was not meant to solar system studies, but as Pedro pointed out, well, CCDs are very inclusive, so we have solar system objects all around. This is just an image of the Blanco telescope at Circle with the DAS camera, the cam, and the prime focus. So, well, we are not discovering any objects, but we are just looking for known objects in the solar system as observed by the document survey. So we use a tool called SkyBody Tracker to find these objects in there. So providing pointing, data observation, site to and field of view to this. It will return all non-solar system objects that may appear in the field of view. So whenever there is an object of interest, we just download all the measurements, astrometric and photometric, from this to our local computers. Here we have a counting of all the objects that we found. And CCD, this is not updated, but we had to freeze the searches at a given moment. So we have a lot of main belt objects as well. In many cases, it's possible to see that covers the solar system from near Earth objects to the regions beyond Neptune. So, okay, we from almost 900 TNOs and Centaurs pointed out to be possibly present in those images. A little bit more than 200 had at least 3 measurements in each of these 4 filters, and well, after some more filtering, we remain with a number of 144. So with these objects, we determine for each object and for each band, we determine the absolute magnitude. Well, the absolute magnitude and the phases will determined from synthetic curves taking into consideration and a non-light curve amplitude and also the uncertainties in the observed magnitude. And with these values, we form 3 colors. And that's where basically our stars, stars. So, well, there does not seem to be a consensus in the literature about the number of classes, taxonomical classes for TNOs. We decided to adopt the classification by Baruch and collaborators that splits the TNOs in 4 classes from the most neutral reflectance spectrum with respect to the sun to the radius ones with 2 intermediate classes. It's interesting to know that there is a good agreement between photometry for the most extreme classes and spectroscopic results. Well, for these 2 intermediate classes, things are a little bit more messy, and sometimes you may tentatively put one object from these classes into the red branch, the red extreme or the blue extreme. And to split the observations into classes, we use an algorithm called PAM, Partition Around Medoids, as implemented in the R statistical package. Well, once we have the 4 groups, we go into each group and determine the reflectance spectrum in each one. And with this plot, we can now identify, well, this group is what we are going to call BB, this is the RR, and these other 2 are the intermediate ones. Well, this is just a brief Here is a table just to compare common objects determined by, whose taxonomical classes were determined by us and those found in the literature. So the agreement is okay. We made, in principle, we did not make any big nonsense in this process. Here's just a description, mostly a description of our data, but it's interesting to see that all classes appear in all different, all taxonomical classes appear in all the different dynamical ones, with the resonant peaking on the IR, and basically only red objects in the code class called dynamical class. And here, well, this is a same major eccentricity plot. And well, you can say here that for the lower end of the same major axis, there are basically blue objects, at least in our sample. Oh, this is a color plot with the taxonomical classes color-coded here, from blue to red. And this is the red in line. And one thing that's interesting to note here is that it seems that there is a smooth transition from the left part of the red curve to the right one for these three classes, whereas the red ones, the departure seems to be more abrupt with respect to this set of displacements here. Well, this is a color eccentricity plot. Again, the taxonomical classes are color-coded. And these are both cumulative curves counts for the bluest and reddest objects. I did not plot all the cumulative curves because this plot would be a mess and there would be no conclusion. At least I could not make any conclusion with all the four curves. So with these two ones, it's possible to see that the largest distance between these two curves occur around 0.35 in eccentricity, and showing significant or important difference in numbers. That means there are much less objects after this eccentricity in the red side of in the red branch of the objects in relation to the blue one. Here we have the same thing, but for inclinations, the color inclination. Here I plotted the four curves. And it's interesting to see that the cumulative curves for the non-bluest objects are basically together here, or the blue curve appears separately. The maximum distance appears around 21 degrees, showing again that there is a difference in objects. There is much less objects for this group after disinclination in relation to the bluest objects. Here we have a color inclination object. We found a weak correlation. By weak correlation, I mean rank coefficient in absolute value between 0.2 and 0.4 for the correlation for the resonant objects. Well, with implications for the evolution of these objects during solar system formation. Another weak correlation between the slope and color. Well, for the slope in the G-band, this slope correlates weakly to all these three colors, whereas we found no, at least from our data, no correlation with the slope in the R-band, and for the I and Z-band, there are correlations with these two colors each here, for the Z-band and for the I-band. Well, I know tables are not comfortable, but it's one interesting thing to see here is that in the G-band, we see a decrease in the steep of the slope from the bluest to the reddest objects. Here, for the bluest objects, we have a decrease in steep from the G to the Z-band, and the other way around to the red objects. Well, also since we calculated absolute magnitudes, we took albedos separated by dynamical class from Miller and collaborators, 2020. And one thing that diameter is all to all the 144 objects. Well, interesting things to be noted here are, okay, we have, if you not consider the error bars, we have no red object with diameters larger than 400 kilometers, and our largest co-dynamical object has a diameter of 255 kilometers. Now this is just a sanity check to see if we have made any big nonsense in the calculation of diameter. So it's a comparison with the literature. So diameters found in the literature and diameters in this work. Here with Aries, here without Aries. And well, taxonomical classes are color coded. So basically things are reasonable. That is, these are not the best diameters in the world, apart from this. But they are useful, but there are many objects without any kind of such measurements. Many of you. So, a few summary comments. So, we have, we believe to have found reliable colors in the 4-group taxonomy defined by Baruch collaborators for more than 100 objects. And, well, one thing that's nice in this classification is that, at least for the bluest and reddest taxonomical classes, there is a good agreement between reflectance spectra and the results from spectroscopy. We found a color inclination and a color inclination weak correlation to resonant objects, and color phase is low correlation also, but mostly to the slope in the G band. No, these results, well, there are references that mention that these things are not exact, are not new. But they break around 21 degrees in an inclination between the counts of reddest and bluest objects. Well, another break around 1/34 in eccentricity for the bluest and the other classes of objects. Well, the slope in the G band correlates with all these three colors, and it could be taken as a rough indication of taxonomical type. And large diameters, at least from our sample, seem likely to be found among the reddest objects. The reddest. Oops. Okay, reddest is double R, not. Sorry, my mistake. And that's it. Okay.
Thank you, Julia. Do we have questions for Julia?
Maybe I missed it, but you were comparing diameter to diameter towards the end of the talk. I wasn't sure where the grading and diameters. I know where those came from, but where?
Okay. Diameters and diameters. This is just a sanity check. These are diameters found in the literature, mostly from Vista and other schools.
Yeah.
And these are the ones determined by this work using the absolute magnitudes from densitometry and albedos from another work. The necessary transformation between colors were certainly made to make things compatible.
More questions? Seems that it was very clear. Thank you, Julio. Let's thank the speaker again.